Hey guys, this is part 2 for 11.4. So if you haven't seen 11.4, the first part, make sure you go back and watch that. This is our last graph. So here we're talking about, we need to find the horizontal or slant asymptotes. We need to find the vertical asymptotes or the holes in our graph. So we're going to have to get to work on that. So first, remember what we're looking for. We're looking to see if this graph is going to be a Bobo graph, a Botten graph, or a eats DC graph. So for this one, we are going to say, okay, the degree of the top is 2 and the degree of the bottom is 1. So this one is a Botten graph. So remember what that means. That means bigger on top, no horizontal asymptote. So we're not going to have a horizontal asymptote. But what that might mean is that we're going to have a slant asymptote. So we need to take my numerator and divide it by my denominator. So I'm going to take my numerator, which is going to be x squared minus 2x minus 3, and we're going to divide that by x minus 2. Okay? So we're going to use this to be able to find what my slant asymptote is. Okay, so now I need to think. To get from x to x squared, what do I need to multiply by? Well, I'm going to multiply by a x. So we're going to go x times x is x squared. X times negative 2 is negative 2x. Then, remember what we do. We draw the line, change the sign. So it's going to be changed to a minus. It's going to be changed to a plus. So x squared minus x squared cancels. And then negative 2x plus 2x, hold on, that cancels too. That's awesome. So all that means is I just need to bring down my negative 3. But x can't go into negative 3, so that is just my remainder. But we don't care about my remainder. We just care about my answer, which is x. So my slant asymptote is going to be y equals x. All right. So let's go ahead. Let's try to graph that slant asymptote on here. So we kind of have to remember how to graph linear equations. So remember, linear equations come in the form of y equals mx plus b, where b is our up and down movement, so our y-intercept, and m tells me how much we go up and over. Now this doesn't really have a whole lot going on. It just has 1 from the x, and it doesn't go up and down at all. So all we're going to do is start here in the center. We're going to go up 1 over 1, up 1 over 1 out this direction. We're going to go to the left, down 1, out that direction. So there is my slant asymptote. Remember, you can always use Desmos or your graphing calculator if you forget how to graph these kinds of things. Okay, so now we have my slant asymptote. Now I need to figure out my vertical asymptotes or my holes to my graph. So so we're going to take a look and we're going to simplify my original equation. So remember, to simplify, we're going to factor the top, factor the bottom. So I'm going to factor the top here. X squared minus 2x minus 3 can become x minus 3 times x plus 1, and that's going to be over x minus 2. Okay, so I don't have any holes because nothing cancels. So since nothing cancels, I have no removable discontinuity. So I have nothing, no holes. We only have asymptotes, so no holes. So none. Okay? All right. Then we're going to look at our vertical asymptote. Remember, is going to be what our undefined is. And so my undefined is going to be x cannot equal positive 2, because that's going to be the opposite of that down there. So I am going to have a vertical asymptote at x equals 2. If that x minus 2 canceled, it would leave me with a hole, a removable discontinuity. But since it doesn't cancel, it becomes a vertical asymptote. And that vertical asymptote I can put on this graph. So I can put my asymptote at x equals 2. So there we go. There is my vertical asymptote. Now, I have 4 sections here. Now I just need to find my x and y intercept to figure out what sections is my graph going to even go into. So let's go ahead and let's grab our, let's go ahead and let's figure that out by finding our x-intercept and our y-intercept. So remember, for your x-intercept and y-intercept, we take our simplified graph and we plug in 0 for x to find my y-intercept, we plug 0 in for y to find my x-intercept. So we're going to change this. We're going to take this guy out here. Y equals x minus 3 times x plus 1 over x minus 2. Okay? So first step, we're going to find my x-intercept. So to find my x-intercept, I'm going to replace my y with 0. So we're going to go 0 equals x minus 3 times x plus 1 over x minus 2. To get rid of that x minus 2 in my denominator, we're going to multiply both sides by x minus 2. Now, x minus 2 times anything is 0. I mean, x minus 2 times 0 is 0, because 0 times anything is 0. So we're going to get 0 equals x minus 3 times x plus 1. I'm going to go ahead and rewrite that as x squared minus 2x. Sorry, my bad. So that we're going to have x minus 3 times x plus 1 equals 0. Hey, check it out. We have two parentheses equals 0, so that tells me what my answers are. My answer for this one is x equals 3. My answer for this one is x equals negative 1. So in this case, I'm going to have two x-intercepts. I'm going to have one at 3, 0, and I'm going to have one at negative 1, 0. Let's go ahead and put that up there on my graph so we have an idea of where my graph is going to go. So we have one at 3, 0 and negative 1, 0. So there are two x-intercepts. Now to find my y-intercept, could not be easier. All we're going to do is take this same equation and plug 0 in for my x's. So we're going to go y equals 0 minus 3 times 0 plus 1 over 0 minus 2. To simplify this out, it's going to be negative 3 times 1, so we'll have a negative 3 on top, a negative 2 on bottom. Negative 3 divided by negative 2 makes a positive 3 over 2, or 1.5. So I'm going to have a graph at 0, 1.5. So there we go. Point a y-intercept at 0, 1.5. So now we can see where my graph is going to go. It's going to be in this top left quadrant and then this bottom right one. So we can draw it hugging this asymptote, coming up, hugging this asymptote, like that. Okay? We can draw it here, hugging this one, and hugging that one. Now, this one is a bit trickier to talk about our domain and range. Now, my domain is still just going to be whatever my holes and vertical asymptotes are. So my domain is still going to be all real numbers, except for x can't equal negative 2. It's going to be negative infinity to negative 2 union negative 2 to positive infinity. Okay? So, but my range is the one that we really need to talk about. My range is going to start here at negative infinity. But it doesn't have a horizontal asymptote anymore. It doesn't have a hard stop. It actually just keeps going up. The angle changes, but it's going to keep going up. That's not going to change. So my range is actually going to be all real numbers, negative infinity to positive infinity. All right? So it's a little bit weirder on this. Whenever you have a slant asymptote, it's a high chance that you're going to have just a range of negative infinity to positive infinity, because it's not a hard stop. There's no hard stop going up and down. We can just glide on keeping going up if there's a slant asymptote. All right? But that horizontal asymptote does give, that vertical asymptote does give us a hard stop whenever we're going left and right. All right, so now let's answer some of these questions down here on the bottom, and then we'll be finished. So first up, how does the horizontal asymptote relate to the range? Well, remember, the horizontal asymptote, or my range, is all real numbers excluding the horizontal asymptote. Okay? And how does the vertical asymptote relate to the domain? Well, the domain is all real numbers excluding the vertical asymptotes and there can be more than one vertical asymptote or any holes in the graph that there are. Okay, so both of those take away from my domain. And last but not least, what causes a point of discontinuity to be removable or non-removable? Okay, a point of it is non-removable. We're going to go the other way. We're going to go, it is removable if it can be canceled. So whenever we factor and cancel, if it cancels out, it creates a hole instead of creating a asymptote, a vertical asymptote. All right? Be sure, as always, let me know if you have any questions. Thank you so much for paying attention. Have a great rest of your day. Thanks.